Myself Padmaja, Associate Professor, Department of CAC, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about interfunction communication and parameter passing mechanisms in functions. So let us start with interfunction communication first. Now, whenever a function gets executed in a program, the execution control is transferred from the calling function to the called function, and once the function gets executed, again the calling function gives back the control to the caller. So there is a kind of communication that happens between the calling function and the called function. So this process of communication between the calling function and the called function is called interfunction communication. Now, in this process, both the calling and called function have to communicate with each other to exchange the information. And the process of exchanging information between calling and called function is known as interfunction communication. So, normally the interfunction communication happens in three ways. So, let us discuss those three ways of interfunction communication. One is known as downward communication, one is known as upward communication, and the third one is known as the bidirectional communication. Now, let us discuss about each one. So, first we'll start with downward communication. Now, what is downward communication? In this type of communication, the data is transferred from the calling function to the called function. So, the functions with parameters and without return value are considered under downward communication. So, whenever you are doing downward communication, in this, the calling function normally passes some parameters or arguments, but the called function returns nothing to the caller. So, this is called one-way communication or downward communication. So, in simple diagram, you can understand here, this is our calling function. So, normally, the calling function calls a function by passing some parameters or arguments. And the called functions receives those arguments or parameters and does the specific task. Now, but the called function returns nothing to the caller. This is called downward communication. Now, in this downward communication, the execution control jumps from the calling function to the called function along with the parameters and executes the function definition and finally comes back to the calling function without returning any value. This is called downward communication. Now let us see one example. For example, we want to do addition of two numbers using a function. So for that, we have written one addition function. So this is called the function declaration or prototype. So this function declaration takes two arguments, both are of integer type, but returns nothing from the your caller. So here we have taken n1 and n2, num1 and num2 are initially 10 and 20, and then we are calling the function. Now we are passing the values 10 and 20 to the calling function. So the function will be called. So these values are stored into the variables a and b. So here a and b are called the formal parameters and num1 and num2 are called the actual parameters. So here this is our num1 and this is our num2 containing 10 and 20. So we are using the call by value mechanism where these values are simply passed into the variables a and b. So now a and b are the local variables where we have received the values from the calling function, and then inside the function we are computing the sum of these two numbers. Now sum of these two numbers is computed and displayed here itself. So the function returns nothing. There is no return statement, explicit return statement. So just after the completion of the function execution, the control automatically goes to the caller and there is nothing to display. So here this is called downward communication. The second type of communication is called upward communication. In this type of interfunction communication, data is transferred from called function to the calling function. That means the function without parameter. The function whenever you are calling, the caller will not pass any parameters to the called function, but the called function returns some value to the caller. So with return value. So the functions without parameters and with return value are considered under upward communication. Now, in case of upward communication, the execution control jumps from calling function to the called function without parameters and executes the function definition and finally comes back to the calling function along with a return value. So let us see how to do it in program. So with the same example, we'll just modify the code little bit. Suppose here addition is a function. We are not passing any arguments. So no arguments are there in the function definition. So simply we are calling the function addition without passing any parameters or arguments. But the function returns you the result of addition, so which you are storing into a result variable. So after storing, then you are going to display the output. So whenever the addition function is called, the control goes to the addition function. And you can see over here in the called function, we didn't receive any argument or a parameter. Now, directly we have declared two local variables num1 and num2 containing the value 10 and 20, and then we are returning the sum of num1 plus num2, so which is nothing but 10 plus 20, which is nothing but 30. 30 is returned. This 30 is integer type, so we have written here int. So this 30 value has to be received by your calling function. So it is received by the variable result and then it is displayed. So it will display the result 30. So here it is called upward communication because the called function is returning value to the caller, but your calling function will not send any parameters to your called function. So it is just upward communication. So you can understand like this. Suppose this is your calling function and this is your called function. So here the called function is returning some value. Return value is there, but no arguments are passed. This is called upward communication. So the third type of communication is called bidirectional communication. In this type of communication, bidirectional means the communication happens or the exchange of information happens from both sides. That is, the data is transferred from the calling function to the called function in terms of the parameters and arguments, and also from called function to the calling function in terms of return value. So the functions with parameters and with return type are considered to be bidirectional communication. So here, in case of bidirectional communication, the execution control jumps from calling function to called function along with the parameters and executes the function definition and finally comes back to the calling function along with a return value. So let us see the example of it. Now let us talk about the same addition example. Here we have declared two variables num1 and num2, and to store the result we have declared one result variable. So in the function definition you can see that the function takes arguments and also function returns some return value. So initially num1 and num2 are 10 and 20. So while calling the function, we are passing 10 and 20. This is called by value. So the value of num1 will be stored into your A. The value of num2 will be stored into B. So after receiving the value, it computes the A plus B and then it returns that value. That return value is stored into the result, your result variable, and then the result is displayed here as 30. So here both ways communication takes place. So you can just have a look at this diagram. So this is your calling function and this is your called function. So here the calling function has sent some parameters or arguments and the called function has returned some values, or it has given the return value again back to the calling function. This is called bidirectional communication. Now, next we'll talk about what are the parameter passing mechanisms. So there are two types of parameter passing mechanisms in functions. There are two types of parameters actually in function. One is called actual parameters and formal parameters. So what is actual parameter? Actual parameters are the parameters that are specified in the calling function. And the formal parameters are the parameters that are declared at the called function. So there is a difference in the terminology. The functions which are passed from the calling function are called actual parameters, and the parameters which are received by the called function are called formal parameters. So when the function gets executed, the copy of the actual parameter values are copied into formal parameter. A copy of the actual parameter are copied into the formal parameter. So there are two ways of doing parameter passing mechanism. So one is called the call by value or pass by value, and call by reference or pass by reference. So you can also call it as call by value or pass by value. And the second one is call by reference or pass by reference. So let us discuss about what is call by value mechanism. So in call by value parameter passing mechanism, the copy of the actual parameter values are copied to formal parameters, and these formal parameters are used in the function. That means originally the actual parameter values are intact, just one copy is passed to the formal parameters, and whatever the changes you will make into the formal parameters will not have any effect onto the actual parameters. So the changes made on the formal parameter doesn't affect the values of the actual parameters. So that means after execution, when the control goes back to the calling function again, the actual parameter values are remaining same. Only the changes happens into the formal parameters. So let us see one example of call by value mechanism. So in this example, we are discussing about how to swap two numbers by writing a swap function here. And for swapping the two numbers, we are using the mechanism here called call by value mechanism. So here we have written the function definition or function prototype, function declaration or function prototype. So here swap is the name of the function which takes two integer arguments or parameters and which returns nothing. So in this case, what we are doing, we are declaring two variables x and y. We are reading the values of x and y, and suppose originally the value of x is equal to 10 and y is equal to 20, for example. So before swap, we are displaying the value of x is equal to 10 and y is equal to 20, we are displaying. Then this line is called call the function. So we are calling the swap function, and we are passing the value of x and y, which is nothing but 10 and 20. So as soon as a function is called, the control goes to the swap function. Now in the swap function, the value of x is copied into A, the value of y is copied into B. So here originally x and y are the two actual parameters, so containing 10 and 20. So these values are copied into the formal parameters A and B. So both are in different memory locations. So just a copy of the actual parameters are copied into formal parameters. But if you talk about the memory address of x and y are different from the memory location of A and B. So A and B are the formal parameters. So after receiving the value 10 and 20, then swapping logic we have written. We have taken one temporary variable and then we are exchanging the value of A and B. So first we are storing the value of A into a temporary variable. So 10 will be first stored into a temporary variable. Then the value of B will be copied here. So the value of B will be copied into value of A, and then finally the value which is there at the temp will be copied to B. So we'll say that the A and B are copied or swapped. So after swapping, we are actually the formal parameter values have been interchanged, but there is no change to the actual parameter contents. So here when you display the value of A and B, you will find the interchange content 20 and 10. So this is called call by value mechanism. Now let us discuss about what is call by reference mechanism. Now in this call by reference parameter passing mechanism, the memory address of the actual parameters are passed to the formal parameters. That means whenever you do some changes to those parameters, then it actually gets reflected in the actual parameter, because you are not passing the values you are only passing the memory address of the actual parameters. So whatever changes are done to those parameters, that is reflected in the actual parameters. So the address is used to access the memory location of the actual parameters in the called function. So in this method of parameter passing mechanism, the formal parameters must be pointer variables because you are passing the address of the actual parameters. To store the address of the actual parameters in the formal parameters, you need to declare the pointer variables because the pointer variables normally stores the address of other variables. Now, it means that in the call by reference parameter passing mechanism, the address of the actual parameters is passed on to the called function and is received by the formal parameters through pointers. And so whatever the changes you make it to the formal parameters are actually affecting the actual parameters. Now let us see through one example. So we are talking about again the swapping of two numbers example here. So here swap is the name of the function. It returns nothing. So what we are passing? We are passing the address of A. Star is nothing but the pointer. So you are passing two integers address. So this is called your function declaration or function prototype. So let us read two numbers x and y. And after reading these two numbers, we are originally displaying what is the value of x and y. So initially you will get x is equal to 10 and y is equal to 20. So x and y are two variables in memory. So x and y will have suppose some address 1000 and 2000 and initially they are containing 10 and 20. So in this mechanism here to the swap function, whenever you call the function, call a function, whenever you are calling the swap function, you are passing the address of x and address of y. So in the formal arguments, these are your actual parameters. Now in the formal parameters, it will receive a and b are nothing but two pointers. So star a and star b, which will receive the address of a and address of b. So these are your formal parameters. Now, after receiving their addresses, so you can see here the formal parameters are nothing but pointers, which receives the address of A and address of B like this. Now, we have declared one temporary variable, then the content which is there in B we are copying to temp and then the content of A is copied to B. So, with the help of a temporary variable, we are trying to exchange the value of A and B. But A and B are normally the memory addresses. So, the actual changes happens here, that is 20 and 10 are exchanged in the actual parameters. So, after swapping, we will get the output of x is equal to 20 and y is equal to 10. Originally, it was 10 and 20. So, now these two variables values have been swapped in memory. Thank you so much. In this video, we have learned about the different types of communication that happens between functions, that is called inter-function communication, and also we discuss about the different parameter passing mechanisms in C language. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.